And boys, let's move on to type 8 question, which are the repeated multiple choice questions for end of the year exam. These all are repeated multiple choice ones, so you have to memorize these answers in red color. Okay, I will read it for you. A current carrying conductor will produce a magnetic field around it. So you know that an inductor is like this. It has a wire or a coil which is wound on a magnet. Okay, so if you pass one current through this wire, a magnetic field will be produced in this one. This is called inductance. Okay, so the question is, a current carrying conductor, which is the coil or the wire, will produce dash around it, that is magnetic field. Okay, unit of inductance is Henry, Henry, and you have to put the symbol in brackets. When the north poles of the two bar magnet are brought close together, there will be a force of repulsion. This is a common general knowledge. Like if you have, there is a magnet has two poles, two sides, south pole and north pole. If two north poles are coming closer to each other, they will repel. Repel means they will move away from each other. Force of repulsion means they will move away from each other. Okay, if one south pole and one north pole is coming closer, it will attract. Like, you know that if you have two positive charges, it will repel each other, it will move away from each other. But if you have a positive charge and a negative charge, they will attract, right? It's similar to this one. So this is force of repulsion because you are coming with two north poles, which means two same signs. Inductance L of an inductor is affected by dash. I told you there are four factors which will affect the inductance: number of turns, area, then permeability or the core material, and one more thing, the distance, the length of the coil. Okay, so all these three are correct. So you should select all the above. Don't read only the first one. Just read all the options and just choose. Maybe there will be all of the above. That will be the answer. In AC circuits, voltage across an inductor leads the current passing through it. I told you, in inductor, voltage is the first wave. Okay, you remember in this one, uh, in inductor, the first waveform was voltage, but in capacitance, it's the opposite. The first waveform was the current. So you should memorize these things. This is very, very important. You can expect the same question. In AC circuit, voltage across the inductor leads the current passing through it. If it was capacitor, it will be current leads the voltage. Okay. When the current through the coil of electromagnet is reversed, what happens? The direction of magnetic field reverses. This is a common sense. Like if you reverse the current, first of all, normally we will give the current from positive to negative, right? If you are giving the current from negative to positive, what will happen to the magnetic field? It will reverse, which means the magnetic field will move opposite. Okay. In AC circuits, current in an inductor lags voltage by 90 degree, which is the same question like this. Uh, this is opposite. Actually, voltage is leading current, which means current is the second wave, right? So current in the inductor, current is lagging voltage by 90 degree. So they will flip. Sometimes they will flip the question. Okay, so you should be more careful. Just keep in mind that for inductor, current is the first waveform. So current is the voltage is the first waveform for inductor. So voltage will always lead. If they are asking about current, the current will be lagging. Okay. According to Faraday's law, EMF is induced when conductor experience a rate of change in flux, which means you know that if you pass a current through the coil of inductor, okay, if there is a current, there will be a voltage, right? So that voltage is called EMF. That EMF will be produced only if there is a magnetic field, right? So this is answer. The conductor experience a rate of change in flux, which means a magnetic field. Guys, this is, I know that it's little bit misunderstanding, but you have to memorize this one. You need to understand deep into this one, because these things only come in multiple choice questions. So just memorize the one in red with the questions. Number of pins attracted to the soft iron rod can be increased by increasing the current. This question won't come in exams because it's not related to your topic, so just ignore this one. Which among the following happens by accelerating the magnet inside the coil? No need. This is also an unusable question. No need. Which among the following circuit elements stores energy in electromagnetic field? Very, very, very important. You can expect this one. The element which stores energy in magnetic field is one and only inductor. The element which stores electrical energy is capacitor, but the one who stores it in magnetic field is inductor. Okay. Moving on to the last question, type 9. This is very simple one. You are provided with a circuit having 12 volt and 60 hertz frequency and an inductor of the value 250 millihenry. You have to find the inductive reactance first. You know the equation, inductive reactance XL is 2 pi FL. First write the equation, then substitute the values. 2 pi is 3.14. Maybe it will be given in the question, or you have to study. Pi is 3.14. F is given 60. Okay, I substituted. L is given 250 milli. So 250 into 10 raised to minus 3. Multiply and put the unit ohms, because inductive reactance is actually a resistance. Now current using Ohm's law, I equals V by XL. So it's given V is 12, so I put 12. XL, I got it 94.2 ohms, so I put here. I will find the answer with the unit A, ampere. Now it's a twisting question. If frequency is 120 kilohertz, find the value of inductive reactance. What you will do? Replace the 6T frequency F with 120, because it's given now 120. So replace F as 120, no, 250. Sorry, this is 120, and 250 into 10 raised to minus 3 is the same, this one. Okay, and find the answer. You will get a higher value. Next is, if the frequency is 30 hertz, find inductive reactance. Instead of 120, just replace F with 30, which is in the question. Find the value. You will get a very low value. Okay. Now, question. Give observations on C and D. What did you observe? If you increase the frequency to 120, you will get a higher value for inductive reactance. If you decrease it to 30 hertz, you will get a lower value of 47. So what did you observe? You observe that inductive reactance increases with increase in frequency. Why? Because they are directly proportional. Okay, so this is the point. That's all from this chapter, chapter 4, which is inductive inductance. These are the important formulas you have to keep in mind. Inductance L is n square mu A by L, where n is number of turns of the coil, mu is the core material, or we can call it as permeability, A is the area, L is the length. Now another equation for inductive reactance is 2 pi FL, where F is the frequency, L is inductance. Ohm's law for inductor is I equal to V by XL, where XL is the inductive reactance. No need for this one, this won't come in your exam. So that's all about chapter 4, inductance.